Hello everyone. Today we're going to be talking about the Sieve of Eratosthenes, which is a way of quickly generating prime numbers. Okay, so let's begin. This method was developed by the Greek mathematician Eratosthenes of Cyrene at around 250 BC. So, how does it work? We're going to look at how it works, and then we're going to also implement it using Python. Okay, so let's begin. So, first of all, we generate a list of all the numbers up to n. In this case, it's going to be 100. We're going to assume that every unmarked grey square is prime. Second step, we're going to start from the square of the number and eliminate all numbers that are composites of the original number. Because if they're composite of a number, that means they can't be prime, right? Okay, hope that makes sense. So the next step, repeat it for every number. And then, eventually, the square of the number will be bigger than n, so all the numbers in the list, all the numbers that remain will be prime. I'll show you the visualization of the algorithm. There we go. Eliminating all multiples of 2, it's going up by 2. Eliminating all multiples of 3, it's going up by 3. Eliminating all multiples of 5, all multiples of 7, all multiples of 11, and the square of 11 is bigger than 120, which is it starts with this list. So all the numbers that remain are prime, which are the numbers shown here. Okay, I hope you get it. So now I'm gonna quickly explain how to implement this using Python. Okay, so let's get into it. So first of all, we're gonna create a function. Let's call it Sieve. I'm not trying to spell the name the guy, so I'm just going to call it Sieve, and it's going to take a number. Okay, so now we're going to generate a list of all numbers, and we're going to all numbers up to our given number, and we're going to say that they are all prime. Range num plus 1. Okay, so now we're going to start from the number 2 because that's the first prime number. And now we're going to do while the square root of p, so the square root of the number we're currently on, is smaller or equal to the number. We're going to check if the number is prime. So if it's in our list and prime is set to true, then that means it's prime. So we're going to check that. Okay? And now we're going to, if it's prime, we're going to eliminate all its multiples. So for I in the range p squared num plus 1, and we're going to go up by p prime I equals false. So the item at that place will be false. And now we increment the list. Okay, so this pretty much is the algorithm. That's how you generate the number, and it's gonna cancel out all of the non-primes. So now, in order to print the primes, we're just gonna create another for loop, and we're gonna go from 2 to the number itself. And now we're going to check if it's prime, then we just print it. So that is the entire algorithm. That is pretty simple, but it's a very powerful and useful algorithm, which I'm going to show in the next video. I'm going to be talking about RSA encryption, and we're going to see how that plays into it. Okay, so let's run the function. And let's give it a number, let's say let's do 10, just so we can see how it works. Now let's run it, and we get 2, 3, 5, 7, which are all the numbers all the prime numbers up to 10. Okay, now, just to show you how quickly it is, let's generate all the prime numbers up to 11. No, sorry, not 11, up to 1,000. And there you go, that's all the prime numbers up to 1,000. So this is it. Hope you enjoyed it. That is quite a short one, but it's a good algorithm to know. Thank you, bye.